Our next speaker for the day is also going to talk, I think, about the importance of data, I can imagine, and his name is Dr. Russel Main, and Dr. Russel Main is a senior researcher at the CSIR. He holds a PhD in geoinformatics from University of Pretoria. It seems like Pretoria is monopolizing here. He is a researcher, as I said, at the CSIR in remote sensing and precision agriculture, with over decades of experience in performing quantitative analysis in remote sensing and research on natural and agricultural land systems. Russel has been involved in multidisciplinary, multi-institutional research initiatives aimed at producing actionable geospatial information using Earth observation data. Recently, he has been leading precision agriculture initiatives in the grain crop sector to make use of multispectral, unmanned aerial vehicles and web-based satellite image platforms to develop products and applications for efficient decision support in the crop sector, grain in particular, for emerging farmers. Ladies and gentlemen, please welcome on stage Dr. Main.
Morning, everybody. Thank you, and thank you, Marius. I think our teams have interacted, and I think very, very relevant points to my presentation as well. So, yeah, as Kenny introduced, so I'm not an agronomist, but our group works in the tech space using satellite imagery, and has recently started focusing that satellite imagery on in the agriculture sector. So, I mean, I think it's well known that, you know, the agricultural space in Africa and South Africa in general faces a number of challenges, particularly, you know, climate variability, productivities, finances. It's a generally low-tech environment, and, you know, is there a pointer here? Yeah. I think that, you know, the difference in outputs is quite evident here, you know, in terms of tons per hectare for corn yields. And I think, you know, one thing to notice here in South Africa or Southern Africa, we're not, like, food security is an issue in South Africa, but in the region where we are one of the more food secure. And I think that, you know, this is not to sort of cast shame, but I mean, there is potential here for us to really increase our outputs here. And it's also notable that in South Africa, you know, this output here is generated by a very small percentage of farmers. And so with our partners, the DSI and the CSR, you know, we're really looking to support the small-scale farmers, the emerging-scale farmers, in helping to boost these numbers and increase the contribution that these farmers make to this overall figure. So, I mean, we are told that, you know, there are these innovation cycles, and at the moment, we're at this intersection of between the fifth and the sixth wave of innovation. And I mean, if anybody's sort of swum in the ocean, I think quite literally it becomes quite important to, you know, the timing at which you either miss or catch waves. And so, yeah, you know, we as a group really want to try and grab onto all of this innovation or some of the innovation that's happening, and roll it out to farmers and assist them in increasing these outputs. So precision agriculture, you know, is this broad concept that we're on this journey towards. We need to try and do more with less. And so this term of precision agriculture is generally about observing, measuring, and responding to within and between field variabilities. It would potentially has the potential to minimize exposure to a variable climate and sustainably optimize inputs and hopefully, obviously, maximize outputs. So we are on this journey to try and, precision agriculture, as I said, broad term. We're looking to use elements within precision agriculture to address the challenges. Beyond individual farms, just last week, the minister announced quite a large pot of money available that's going to be available for emerging farmers, small-scale farmers. And so, using technologies such as satellites and drones and this broad concept of precision agriculture, there's should be this ability to conduct monitoring and evaluation in order to efficiently manage, where this money is going from. We have fielded in the past a number of queries from government departments. How do we know that farmers are using the grants that we're giving them for farming and not for other purposes? So, the technologies that I'll be talking about today, we hope will give like an independent traceability for both funder and farmer. Farmers would also hopefully be able to use this information to prove that, they are doing what they're doing. I think that, one of the old sayings is like, if you're not measuring, then you're not managing. And I think this is something that we'd like to try and install and take further. Okay. So drones and UAVs are a space that we're getting into. This report by the African Institute of Entrepreneurship really paints a nice picture of the current state of the drone industry in South Africa. And I think the key sort of takeaways here is that drones and UAVs are just generally exploding everywhere. In the US, there's billions of dollars of investment into it. Many hundreds of thousands of pilots and drones registered. And despite South Africa being one of the first countries to sort of present fully fledged regulations, there's this perception in this report that to date, only well-capitalized and organized entrepreneurs have actually managed to create businesses around drones in South Africa. And, the numbers are quite low, only 83 operators and under 2,000 pilots in the country. So, again, the sense here is that this could be a lost opportunity to develop new industries and create jobs, especially amongst the youth. I think that young people, a cell phone and a drone, and they'd be sort of happy for days. And I think there's opportunity in there to bring out value. Sorry, it's being a bit slow. Okay. So, the appeal is there. Farmers appreciate detailed bird's-eye views of their fields. Some of these drones are capable of like centimeter resolution data, really high-res data. We've worked with some emerging scale farmers out in the Vereniging region, and showing them drone data was just amazing to them. They really appreciated knowing in their fields where things are happening. We took some images even where this farmer had contracted the planting of his maize, and you can see there's different densities here compared to there. You can see more soil than over here. there's gaps in where the planter malfunctioned or something. And he was really grateful to have this imagery to go back to the contractor and the insurance and say, listen, this happened, how it was too late for him to replant, but he was going to try and get restoration from. So yeah, there's all this value, especially if you continuously do it. However, there are still barriers in terms of cost and the complexities associated around drones. You have to buy a drone, you have to get the right software, you have to know how to stitch the images together, you have to know what you're sort of looking at, especially if you're dealing with sensors that are not just the usual RGB, red, green, blue images. So the CSIR is on this journey to try and address some of this. We've just recently purchased a pretty advanced drone, maybe the only one in the country. It's an integrated hyperspectral and LiDAR capabilities. It's going to give us the opportunity to build not only 2D but also 3D sort of data cubes of information. It's going to allow us to detect very subtle changes in the plant condition that's usually not noticeable by the eye, the naked eye, or your off-the-shelf type of sensors. So this will give us the ability to detect, study, and recommend specific solutions to domain challenges. If there's a particular sector or farmer that has a problem with a disease or something like that, we are hoping that we will use this drone as the sort of microscope to maybe the binoculars of the farmer's eyes. This is really going to give us highly precise information, really go in, target the disease and the spectral properties of that disease, and then figure out a software solution or even a hardware solution. This drone doesn't fly very far or for very long. We're hoping to, which I'll touch on later, use the capabilities within the CSR to degrade or to bring out some of that information from the high precision data and scale it up to satellites, maybe produce low-cost sensors, and these sorts of things. So, yeah, this is something that we hope to work on with this drone. Beyond just what we can see here, beyond the horizon, very busy slide, but basically all metrics are showing that satellite data is just exploding as well. Just more and more satellites being launched, more and more data being available. This is also something that we're looking to tap into. This obviously, as I just mentioned, gives us a nice opportunity to take field data, expand these insights onto drone data, which might be at a couple of hectares. This is obviously point sampling to a couple of hectares, maybe even 100 hectares. And then we use some modeling, machine learning, AI type algorithms, and then take these drone insights, so these drone images, and scale it up to maybe a regional scale satellite image, where Department of Agriculture or the like can get regional scale insights, not just at the farm level. Cloud-hosted satellite data, along with that explosion in the launch of satellites, the satellite data is being hosted now online. It's becoming analysis ready in a way. Many years ago, you had to download an image, have special software, and then run it through a workflow just to use it. Nowadays, many of those steps are already being completed, and it's all available within a web browser with no real specialized software. A little bit of a learning curve in terms of accessing it, but it's got great potential. And I really like this quote here: "Data is increasingly becoming the new soil from which businesses and economies can grow." So we're on this journey to set up an information system that's going to try and bring all of this together and support industries along the value chain with actionable farm-level data or intelligence. So we're hoping to collect sensor data, UAV data, satellite data, and make it available to the farmer. We've started setting up this platform where this will be available. Satellite data is going to be available at farm level. Some of the examples of products, again, I like the language that Morris used, really on this journey to try and, farmers don't understand, in our terms, a simple index is an NDVI image. But, we really need to sort of work on that messaging and bring it to parameters that farmers understand, such as stem height in the maize case, not just, oh, here's an image of your farm, but really bring out parameters that show stem height. Statistical anomalies, we've got time series of data. We'll be picking out interesting anomalies in that data and trying to present that to farmers. And yeah, we're in a number of collaborations, FarmSol, an incubator for emerging farmers, Department of Agriculture, Bushler Farmers Academy, and a number of others. And then within the CSR as well, we're really looking at collaborating. We're very fortunate in the CSR to have a number of great divisions working on robotics, indigenous knowledge systems. We can't just go and replace centuries of knowledge, of agricultural knowledge, and just say you must use technology. We need to figure out, how to get this information and join it with indigenous knowledge systems. We have people working on rural whites, bringing internet to rural places. Photonics, we will try and work with bringing out insights from the drone. And so, yeah, we are on this journey to looking to support farmers and industries, hopefully improve yields, profits, enable climate adaptation, and really build these sort of ecosystems of innovation in the CSR and broadly. And also, capacitate farmers and create jobs, invite the youth into using all of these technologies, and ultimately try and help improve food security. Thank you.